Corporate planning often operates under the assumption that the future is a machine. We believe that if we can map every gear and spring, we can manage the world with mechanical precision. Organizations commission endless business cases, develop elaborate scenarios, and deploy increasingly sophisticated models, all designed to force an unpredictable tomorrow to behave predictably. Yet the most consequential decisions an enterprise makes rarely wait for clear skies. They happen when information is fragmented and assumptions are highly contested. When the environment changes faster than a model can be updated, the cost of delaying a decision often outweighs the risks of acting on incomplete data. Legacy architecture designed complex, monolithic blueprints for certainty, assuming linear progression toward a 3 to 5 year target state. Then, reality hits. Sudden technological or regulatory shocks instantly invalidate those assumptions. In tightly coupled systems, a single unexpected variable causes cascading errors throughout the entire structure. The flaw of traditional architecture is the expectation that the future will cooperate with the blueprint. Today, we operate in an environment defined by geopolitical friction, rapid deployments of artificial intelligence, and evolving cyber threats. These forces shatter static plans. This fluid network illustrates how a resilient organization operates. Instead of attempting to control every external factor, they acknowledge what they cannot predict. They concentrate their energy entirely on governing what they can, their internal domains, standards, and capabilities. The objective of modern architecture is no longer to design a predictable future. The objective is to design an enterprise capable of sustaining its core functions, dynamically bypassing failures, even when the environment becomes chaotic. Uncertainty must be accepted as a permanent characteristic of the operating environment, not a temporary glitch that will eventually be resolved. But acknowledging that unpredictability exists can never be used as an excuse for organizational paralysis. Refusing to wait for certainty before making strategic choices is the defining characteristic of modern architectural leadership. Market movements, competitor actions, and consumer behavior belong to a turbulent environment that an organization can never fully control. However, the enterprise retains direct control over its operating models, data practices, and technology standards. Managing these internal controls effectively introduces a core architectural concept: degrees of freedom. This scale illustrates how choices impact optionality. On the left, a massive, tightly coupled system eliminates choices, trapping the organization. Heavy dependence on a single provider acts as a tether, restricting maneuverability. Moving right, a modular organization with APIs possesses options to swap components. By institutionalizing knowledge into replaceable components, rather than locking it inside fragile dependencies, the enterprise becomes highly adaptable. The central question for an architect shifts from asking what architecture will be needed in 5 years to asking what architecture provides the most viable choices when assumptions fail. Every design choice, from API definitions to domain boundaries, collectively dictates the organization's future maneuverability. We must acknowledge an economic reality. Optionality comes at a high cost. Maintaining full portability across 5 different cloud providers requires immense capital and overhead. Designing every system to account for every possible future is neither practical nor economically viable. This matrix illustrates real options thinking, deciding where to invest in flexibility. The x-axis maps environmental uncertainty. The y-axis represents the operational consequences of being wrong. High uncertainty, combined with severe consequences, justifies paying for alternatives. This top right quadrant is where you invest in optionality. Outside of this high-risk zone, standardization should be aggressively applied to prevent unnecessary variation and accelerate product delivery. These standards must exist strictly to create leverage and speed, rather than to uphold bureaucratic traditions of how things have always been done. There is a persistent misconception that if you just gather enough evidence, you will eventually eliminate all uncertainty before having to make these investments. You won't. The enterprise must deliberately invest in flexibility as a targeted strategic option, rather than treating it as a blanket engineering mandate applied to everything. When faced with the unknown, organizations frequently regress. They rely on executive preference or copy industry analysts, searching for direction when none exists.
Empirical architecture provides the antidote to endless internal debates about whether a platform will scale or if customers will adopt a new capability. This diagram shows the empirical loop, a continuous cycle of observing reality, experimenting, measuring outcomes, and testing assumptions. By implementing new patterns within a bounded context, teams can measure results safely without exposing the entire enterprise to risk. This testing is paired with a discipline known as productive paranoia, the practice of constantly asking, "What happens if we are wrong?" It forces the organization to confront severe scenarios, cloud providers failing, critical data being compromised, or AI models behaving unpredictably as they scale. The architectural expressions of this paranoia are redundancy, robust disaster recovery protocols, and graceful degradation. The objective is not to build a system that prevents every possible failure, because that is impossible. This model illustrates the true goal, ensuring that when individual failures inevitably occur, they do not cascade into company-ending events. Rigorous preparation and bounded testing convert paralyzing uncertainty into the freedom to act decisively. Traditionally, enterprise planning followed a strict linear progression. Business strategy defined the requirements, architecture translated them, and technology simply executed the orders. Operating in a highly volatile environment completely reverses this dynamic. This diagram illustrates that reversal. Today, technology dictates what the business is capable of doing, and artificial intelligence actively alters operating models in real time. Today, the enterprise functions as a continuously evolving system, dynamically branching and adapting its shape to navigate around sudden obstacles. Consequently, the enterprise architect must evolve from being the designer of a static target state to becoming the designer of adaptive capacity. The true metric of architectural quality is now based on speed, how quickly it can detect change, how quickly it can experiment and reverse its failed decisions. High-performing organizations do not possess better foresight than everyone else. Instead, they develop behavioral mechanisms to respond effectively when reality diverges from their expectations. This response is built on 3 enduring principles. The first is fanatic discipline. This means standardizing what actually creates leverage for the business while fiercely resisting bureaucracy disguised as architecture. The second principle is empirical creativity. It demands that we replace comfortable assumptions with hard evidence to build the confidence required for action. The third principle is productive paranoia, which ensures we build buffers, redundancies, and strategic options long before they are ever needed. Together, these 3 principles allow an enterprise to rapidly adapt without losing its core identity, and to innovate while maintaining systemic control. The best architecture does not predict the future. It gives the enterprise the freedom to respond when the future refuses to cooperate.